In 2022, Switzerland lost 6% of all its remaining glacier ice in a single year. Not over a decade, not over a generation. In 12 months. Then, in 2023, it lost another 4%. 10% of Switzerland's total glacier volume. Gone. In 24 months. That same 10% had previously taken 30 years to melt. This is not a story about a gradual environmental change that future generations will have to deal with. This is a story about an acceleration that is already rewriting the physical geography of Europe in real time, with consequences that will reach from the Swiss Alps to the ports of Rotterdam, to the rice fields of the Po Valley, to the electricity bills in Stuttgart. The glaciers are not just melting. They are collapsing at a pace that has outrun every projection made as recently as 10 years ago, and most of the damage cannot be stopped anymore. Even if every emission on Earth stopped tomorrow, let us understand why and what it means for the 90 million people downstream. To understand what is happening to alpine glaciers, you first need to understand why glaciers exist at all. A glacier is not simply a large patch of permanent snow. It is a dynamic system in constant motion, fed by winter snowfall, at its upper elevations and losing ice through melting at its lower edges in summer. When snowfall at the top equals melt at the bottom over many years, the glacier stays roughly the same size. When the climate warms, the balance tips. More melts in summer than accumulates in winter. And year by year, the glacier shrinks. Switzerland's glaciers have been retreating since the end of the Little Ice Age around 1850. That part is not news. What has changed is the rate. The Swiss Glacier Monitoring Network, which has been measuring glacier mass balance since the late 19th century, has documented an acceleration in the past 2 decades that has no precedent in the observational record. The Rhone Glacier, one of the most visited in Switzerland, a source of the Rhone River that flows through Lake Geneva and into France toward the Mediterranean, has lost 3.4 kilometers of length since 1900. For most of the 20th century, that retreat was roughly linear, slow, observable across decades. The retreat rate over the last 20 years has been nearly 3 times the rate of the previous century. The Aletsch Glacier, the largest glacier in the Alps, stretching 23 kilometers through the canton of Valais, has lost more than 3 kilometers of length over the past 150 years. The pace of loss in the last decade alone accounts for a disproportionate share of that total. ETH Zurich, Switzerland's federal technical university and the world's leading authority on alpine glaciology, released modeling work using satellite data, machine learning, and high-resolution topographic surveys that produced a conclusion too stark to soften. Under current emissions trajectories, more than 90% of Swiss glacier volume will be gone by 2100. The smallest glaciers, those under 1 square kilometer in area, are projected to disappear entirely by approximately 2027 to 2030. Not by 2100, not by 2050, in the next 5 to 7 years. But here is the piece of science that most coverage misses entirely, and it is the most important piece. Even if warming stopped today, the glaciers would continue melting, significantly. Scientists call this committed glacier loss, and it works like this. The climate system responds to greenhouse gas concentrations with a time lag. The warming we are experiencing today is not caused by the emissions of today. It is caused by the emissions of the past several decades, which have already accumulated in the atmosphere and ocean. The oceans in particular absorb an enormous amount of heat, and they release it slowly. The ice sheets and glaciers responding to temperature changes do so with their own lag. This means that even in a scenario where humanity achieved 0 net emissions tomorrow, the temperature would continue rising slightly for years, and then remain elevated for decades before beginning to fall. During all of that time, the glaciers would continue losing mass. Swiss glaciologists estimate that approximately 1/3 to 40% of Switzerland's remaining glacier volume is already committed to melt, regardless of what happens to emissions in the future. That ice is thermally destined. It is responding to warming that has already occurred, that is already baked into the physical system. The metaphor that scientists use for this is haunting. The glaciers are bleeding water, and much of the bleeding has already been decided. The only question is how much more gets added to it by the choices made from today onward. Now let us talk about what glaciers actually do. Because the most important shift in how we need to think about this crisis is to stop seeing glaciers as beautiful scenery and start seeing them as infrastructure. Essential, irreplaceable infrastructure. The Rhine, the Rhone, the Po, the Danube, the Inn. 5 of Europe's most economically critical river systems either originate in or receive significant contributions from alpine glacial meltwater. These are not abstract geographical facts. They are the arteries of European civilization. Take the Rhine. It carries approximately 80 million tons of cargo every year, making it one of the busiest commercial waterways on Earth. Chemical plants, power stations, steel mills, and agricultural enterprises along its banks depend on consistent flow for cooling water, transportation, and industrial processes. Germany's chemical industry, one of the largest in the world, is disproportionately concentrated in the Rhine Valley. In 2018, a summer drought that reduced alpine snowmelt and glacial contribution caused Rhine water levels at a critical gauging point called Kaub to fall below 40 centimeters. Below that level, heavily loaded barges cannot navigate without running aground. Traffic on the Rhine was suspended or dramatically curtailed for weeks. The economic cost of that single drought event was estimated at approximately 2.5 billion euros. BASF alone, Germany's largest chemical company, spent more than 200 million euros on emergency logistics alternatives. In 2022, it happened again. For weeks, the Rhine ran at levels that made normal barge traffic economically impossible. Fertilizer shipments were delayed. Coal shipments to power plants were disrupted. The global supply chain stress that was already straining European industry in the post-pandemic period was compounded by a river that simply did not have enough water in it. Here is the critical point about what the glaciers provide that pure snowmelt cannot replace. Glaciers act as a buffer. In summer, when rain is scarce and temperatures are high, glacial meltwater supplements river flow. The glaciers are essentially frozen reservoirs, accumulating water in the form of ice through wet seasons and cold years, then releasing it precisely when it is most needed, during the dry, hot months when demand for water is at its peak. When the glaciers are gone, that buffer is gone. Rivers fed primarily by seasonal snowmelt become dramatically more volatile. Heavy precipitation years bring floods. Dry, hot summers bring drought. The smooth, reliable flow that European agriculture, industry, and power generation have been built around for 2 centuries becomes unpredictable and extreme. Italy's Po Valley produces approximately 40% of Italy's total food output. The Po River, which flows from the Western Alps eastward to the Adriatic Sea, is already experiencing serious low-flow events in summer that are forcing irrigation restrictions on farmers who have depended on its reliable summer flow for generations. Northern Italy experienced its worst drought in 70 years in 2022. Po Valley farmers watched irrigation cuts that damaged crops of rice, corn, and tomatoes. Switzerland generates approximately 56% of its electricity from hydropower. A significant fraction of that hydropower depends not just on precipitation, but on the timing and volume of glacial meltwater, which flows most reliably in summer when electricity demand from air conditioning and industry is highest. As glaciers shrink, this timing reliability degrades. Eventually, the glacier-fed summer flow supplement disappears entirely. The temporary fix that has become iconic in photographs of the Alps is the glacier blanket, large sheets of white or reflective synthetic fleece rolled out over exposed glacier surfaces at ski resorts to reduce summer ablation. Studies show these blankets can reduce melt on covered surfaces by 50 to 70%. Tourists photograph them. Media stories describe them as innovative adaptations. They cover approximately 0.1% of total glacier surface area. They work only in small areas directly above economically valuable ski infrastructure. They have no effect on the atmospheric conditions that are driving the melt. They are, in honest assessment, a band-aid on a wound that requires entirely different medicine. The scientific and engineering community has known the trajectory of alpine glaciers for decades. The first credible modeling of glacier response to greenhouse gas warming emerged in the 1980s. The trend lines were established. The projections, which have, if anything, turned out to be optimistic, given the actual acceleration observed in the 2020s, were available. Europe had 40 years to begin building the water storage infrastructure, the alternative hydropower systems, the drought-resistant agricultural varieties, and the river management frameworks that a glacier-free alpine future will require. That work has begun in some places. Switzerland and Austria have invested in new mountain reservoirs designed to capture precipitation and snowmelt in the absence of glacial buffering. France has undertaken some agricultural adaptation work in the Rhone Valley. Germany has updated drought emergency protocols for Rhine navigation. But the scale of adaptation that the data demands has not been matched by the scale of investment that governments have committed. The German Rhine Navigation Authority still operates on assumptions of river flow that will be increasingly unreliable. Italian farmers in the Po Valley are still planting crops designed for water availability that will not consistently be there. Swiss hydropower companies are projecting revenue based on meltwater contributions that are committing themselves to a lower trajectory every year. The glaciers are not coming back, not in any time frame that has meaning for human civilization. Heath, Zurich's models project that under the most optimistic realistic emission scenario, between 60 and 80% of Swiss glacier volume will still be gone by 2100. That residual is not recovery, it is a remnant. The largest glaciers will persist as smaller, higher altitude ice fields for longer. But the network of valley glaciers that has shaped alpine hydrology, landscape, and human settlement patterns for thousands of years is in terminal decline. The practical question that Europe now faces is not how to save the glaciers. They cannot be saved at a civilizational scale in the time available. The question is how to live without them. How do you replace a buffer that has been accumulating and releasing water on a reliable seasonal schedule for 10,000 years? How do you build enough reservoir capacity to substitute for that function at the scale needed by 90 million people? How do you restructure agriculture designed for one water regime to function in a different one? How do you redesign a hydropower system built for a meltwater contribution that is declining every year? These are engineering questions. They're governance questions. They're economic questions. And the answers require investment that has to start now, because the infrastructure needed takes decades to build and the glaciers are not waiting. Switzerland lost 10% of its glaciers in 2 years. The time to treat that as an emergency is not when the next 10% is gone. It is now. While there is still glacier water flowing down the Rhine and the Rhone, while there is still summer melt to buffer the droughts, while there is still time to build what comes after. Because what comes after is already decided. The physics are settled. The commitment is baked in. What is not decided is whether humanity builds for it or waits until the rivers run dry to start asking the question.